Hey everyone, in this video let's take a look at question 19, remove nth node from end of list on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, we're given the head of a linked list and we want to remove the nth node from the end of the list and return its head. In this first example here, we have the list 1, 2, 3, 4, 5 and we're given n equal 2. So what this means is we want to remove the second last item from the end of the list. This is the last item, so this is n equals 1. This is n equals 2, the second last item. Essentially, our new list is going to be 1, 2, 3, and 3 will connect to 5. Basically, this 4 will be removed. Let's say we had something like just one node and n equals 1. Well, in that case, we would just remove the head, right? We would just remove this last node, which happens to be the head. And so if we don't have the head, then we have nothing. If we have 1 to 2, so 2 nodes here, and we want to remove the last one, well, then we just remove the 2, and then we just have the 1. We just have head pointing to nothing. So let's see how we might be able to do this. And really, if you think about it, all this question is asking us to do is like, we already know how to delete from a list. We already know how to delete from a list. So now the question is, how do I find this last element? How do I find this 4? How do I find the nth element from the end of the list? So how can we do that? Well, there's a couple of ways. Let's maybe discuss probably the most obvious way, and then we can see if we can somehow improve it. So what is the obvious way? Well, first of all, notice that we can't just get this n out of nowhere, right? We can't just get this out of nowhere. We have to, first of all, traverse through the list, and we can go to the end of the list, right? And then maybe we can understand what the n is. So how can we do that? Well, think about this, right? So if I'm going through the list, then I can maybe just store the indices of each node, right? So maybe I can say that this 1 is at index 0, this 2 is at index 1, this 3 is at index 2, this 4 is at index 3, and this 5 is at index 4. Now, if I have this information, then what I know is basically, what is my n? N is 2, right? So if I have like the length of the list here, the length of the list is essentially 5, then I can basically just do 5 minus 2, which gives me 3, and then I already know what is at node 3, right? I already know what is at index 3. It's this 4 over here. So maybe we can start off with that approach. When we go through the list, the first time, we will actually just set up a mapping index to this mapping over here. And then once we are done, then we can figure out what the node is that we want to remove and then go ahead and remove it. So let's maybe go ahead and start with that and see where that takes us. So in this first case, first of all, head can be empty, right? Head is optional. So if head is not provided, then let's just return whatever is given, because then n doesn't have any meaning. Now, otherwise what? Well, otherwise, we need to go through our list, right? So we can just traverse like this. So we can do while cur, and then we can do cur is equal to cur.next. So this will go through the entire linked list. But now we also want to store this information inside of a hash map, right? We want to store that 0 maps to 1, 1 maps to 2, etc. We want to store this in our hash map. Let's maybe have a map here, dictionary. And I'll also have an index variable, which I'll call I. And so what will I do? Well, before I do cur is equal to cur.next, let me maybe do something like d at I is equal to cur. So this one will basically map the 0th index with the first node, 0th index with node 1, first index with node 2, etc. Right? So once this is done, we need to actually increase our index by 1. Now we've increased our index. Okay. So now what do we have? So now we have a hash map of all of the indices mapped to the specific nodes. And we already argued here that basically in order for us to find what is the nth node from the end, all we need to do is we need to do like I, which in this case, I will actually be out of bounds, right? Because if you think about it, I plus 1 here at the very end, after we do the cur equals cur.next, at the very end, I will be here, but then we'll do I plus 1, so I will actually be outside. So if you think about it, I now represents the size of the list. So we can just do node that I'm looking for is essentially just I minus n. That is the indice of the node, and then we can look in our dictionary to see what that node refers to. So now we'll get the node 4. Okay? So now we have the node 4. So how do we go about removing nodes? Well, there's a couple of cases, right? First of all, what we need to do is we can just check if node is equal to head, then how do we remove the head? Well, we can just return head.next, right? We can just return head.next. If we have maybe to remove this, let's just return head.next, which may or may not be none, but we're just removing the head. So that's our simple case. Otherwise, how do we go about removing nodes? Well, it's very easy, right? All we really need to do is we need to point this 3 to this 5 over here. So how can we do that? Well, we've done this in other problems, but we can basically keep a previous variable and a current variable, right? And when current arrives at this existing one, we can just go ahead and break. And then this previous one, we can point the next pointer of this one to the next pointer of cur. So let's take a look at how that can happen. So we will have previous is equal to none, cur is equal to head, and then we'll loop till cur exists. And then we can do something like this. First of all, if cur is equal to my node, then let me go ahead and break. Otherwise, I'll set previous equal to cur, and then cur is equal to cur.next. So when we are outside here, basically cur will end up on here, and previous will be the previous value here. Okay, so that's all good. Now we know previous and cur, it's not head, right? Because we already handled that case over here. All we need to do here is previous.next is equal to cur.next. And we know since we haven't modified the head, we can just return the head that we have. So let's try this approach to see if we can run the test cases. Okay, perfect. Let's go ahead and submit. And perfect, so this approach works. Now, this approach is O of n time, but you might notice it's O of n space as well, because we're storing all of the nodes inside of the hash map. So is there a better way to do this? Well, yes, there is a better way, and the better way actually uses 2 pointers. So 2 pointers is, we've done this in another problem, I believe. I think we did it in the one where we want to find if there was a cycle potentially in the list of nodes. But how does a 2-pointer approach work? Well, a 2-pointer approach, essentially what we have is that instead of just cur, we have maybe 2 pointers, right? So we have cur and we might have something else. And often they start off at the same place, like we might have cur1 here, cur2 here, but they don't necessarily need to. Maybe cur2 actually starts off at the second value here, right? Etc. So what would kind of make sense here? Where would we want like cur1 to start off and cur2 to start off? Well, 1 pointer always starts off at the root, so we can keep this 1 pointer here. But what about another pointer? Where should cur2 start off? Well, if you think about this one, why don't we, let's say n is equal to 2, right? Let's say n is equal to 2 here. So what would I like in the very end? Well, what I would like is I would like my cur pointer to be here and my cur2 pointer to be basically out of bounds, right? Out of bounds. My cur2 pointer, whenever it stops, then I know that my cur pointer has arrived at the answer. So I kind of want something like this. If my cur is at the answer, then I want my cur pointer to essentially be out of bounds, or maybe it's something like, let's say this actually connects to something like a 6, right? Or maybe it goes to a 7, etc. Whatever. But we know that cur2 has to be ahead of cur. But in this case, we notice that it actually has to be out of bounds, right? Why? Well, think about it this way. What can we set cur2? Well, if we set cur2 just to this, like the next pointer here, we can't really understand anything about n, right? So we have to somehow use n in determining like where we want to set our cur2. Well, why not we set our n, or why not we set our cur2 basically n distance away from cur1? So n distance away, in this case, it would actually be over here, right? So why don't we maybe do something like this? If we do something like this, what happens? Well, if we do something like this, we set cur1 as the head as we always do, and cur2 n distance away, then basically every time these nodes move, cur2 will come here, cur2 will come here, and then finally cur2 will be out of bounds. But you can notice that cur2, if it's out of bounds, then it is n distance away from cur1. And so cur1 will actually be at our target node. If you think about it like that, we can use that type of approach here. We can set cur2 to be basically n distance away, and then we can advance cur2 all the way to the end, and wherever cur1 ends up, that is our n node. So let's take that approach here. So in that approach, I actually don't need a dictionary, so I can go ahead and remove all of this logic here. What can I do? Okay, so first of all, let's go ahead and find n nodes away, right? So first of all, let's go ahead and find this location here that we're going to initially set cur2 as. How can we do that? Well, we can do while cur, right? And n is greater than 0. What can we do here? Well, first of all, n we need to decrease by 1, and then cur we can equal to cur.next. So basically what's going to happen now is here initially n is equal to 2, and now n is equal to 1, and now n is equal to 0. So at this point, essentially, we're going to go ahead and break out. Okay, so now we know essentially we can say n distance away is equal to cur, and now we can go ahead and we can loop again, but this time we will go until this value is basically out of bounds, right? If it's out of bounds, then we know we are at the target. So what can we do? We can do while n distance away, right? And we also need a cur in this case, which we will set to head. So we can advance cur, and we can advance n distance away. And we know that when n distance away is out of bounds, then cur must be at where? Must be at my target node. Okay, so we do that. So now cur is essentially at my target node here. And so after this, basically none of this needs to change. So we can just set node equal to cur, because we know cur will be at our target location. Now let's go ahead and run our sample test cases to see if they pass. Okay, let's go ahead and submit. Okay, perfect. So this is the working solution. Now the time here actually remains the same. It's O of n, but the space here, notice that it is constant space. We're not using a set to store or dictionary to store our nodes. So that's this problem.